Good evening, Professor. I'm here to share my probability of winning the lottery assignment. Let's get started. So, when I started looking into winning the grand prize, one thing that we need to understand is that we are working with a discrete probability, not a continuous probability. So, we need to know that there is a finite number of combinations. So I use the combination formula from our textbook, chapter 5, to help me calculate this number. But then it turns out Python has this in math when you import it. And that was a lot easier, and it definitely takes out human error. So that's what I used. So to figure out the probability of winning the lottery, you have to, find the total number of divide it 1 by the total number of combinations. Oh my gosh, I'm losing my mind right now. Hard to talk sometimes. So the probability of winning the lottery is really, really small. And I know that this wasn't part of the assignment, but to make more of an impact and for people who hate math like me to understand a little bit better, I wanted to put this in form of a percentage. So the probability of winning the grand prize in percentage is so very small. It's practically impossible. I would not ever take bets on that. No one should. So to get the probability of Alexandra winning at least once, it was Alexandria, but I guess it's Alexandra, over an 80-year span, with, buying a ticket every day for 365 days at $5 a ticket. This is the code that I came up with to calculate that. So we had to multiply the lifetime of years by the days per year. And then we had to calculate the complement, which I also got from the textbook, chapter 5. So again, I wanted to calculate the percentage to make more of an impact because that says more to people who hate math, again, like me. So the probability of winning at least once, 0.001620, blah, 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 that is, again, absurd. The probability of winning at least once in percentage is the same as this one up here of winning the grand prize, because that's what she's trying to win. And the total money spent, while over an 80-year span, I guess isn't that bad, but I would rather spend this much money on a cup of coffee every day than a lottery ticket. So $146,000 just seems like an absurd amount of money to me. So then we needed to calculate the various epsilon values. That's what we were tasked with in task 3. So once we calculate these epsilon values, we can kind of figure out more of those chances of winning. Like we have more of an idea. So I had to translate this for myself to talk about because I'm not used to talking about epsilon numbers in terms of probability. So this first one represents a low probability threshold. It indicates that you need to purchase at least 181 tickets to have a greater than or equal to chance of meeting this epsilon value. The next one, there's a slightly higher probability of winning at least once if you purchase 18,000 tickets. And then this epsilon value represents a 10% chance of winning, which means you need to buy almost 2 million tickets just to have a 10% chance of winning the lottery. I don't even want to know how much money that would be. That's so much money. And then this one would be the 50% chance. And I recalculated this so many times, and you can see in the next step where I recalculated how many friends this guy would need, but 12.5 million tickets to get a 50% chance. That's wild. So to increase the probability of winning to above 0.5 or 50% without adding more people, Amir must be really popular because he would have to have 12.5 million friends, and assuming everyone bought one ticket. 12.5 million friends. And so I thought that was insane, even though it's up here, which I also thought was insane. I ran this a few times and was like, well, let's just keep going. And then I ran it down here and was like, oh my gosh, that can't be right. So I did it a little differently down here, which essentially is the same, but just to make sure I didn't like fat finger something. It's still 12.5 million friends that he would need. So 12.5 million it is. So the probability of winning the consolation prize, to calculate the consolation prize, we had to do three different combinations, really. the correct numbers, the incorrect numbers, and then the total combinations. And then we had to multiply those, the correct and incorrect together, and then divide it by the total combinations to get the probability of those, or of this particular consolation prize. So the probability of winning the consolation prize is, again, really, really, really small. Terrible, in fact. But the consolation prize is only $1.50. So I'm not sure where you would want that. Anyway, this is why I don't gamble. Probability is against us. So here are my sources. I use ChatGPT to help me check some of this math because, like I said, it just seemed really absurd to ask someone to have 12.5 million friends, but here we are. So thanks, and I'll see you next week.